Hey everybody. Purpose of today's video is to go over how to use integral calculus to find the area between two different curves. This has applications in manufacturing. If you're manufacturing something that has an oblique shape like this, where it's not a regular polynomial, you can actually figure out the amount of materials required to make a shape such as, well, this one, which might resemble something from a Pepsi logo. Anyway, we have the red parabola represented by this function y equals x squared minus x, and the blue parabola represented by 2x minus x squared. And the algorithm goes, if you find the area under the top curve and then subtract the area around the bottom curve, that you're going to get the area in between. And so there's some notes on this that you can look up and understand how the algorithm works and why it works, but the gist of it is you literally use integral for areas, and then we take the top curve, the blue curve, y1, and subtract y2 and dx. But then here's the issue. We have to find the area from this intersection to that intersection. Now, because of just common sense, both of these parabolas have a y-intercept of 0, so that's why I know I'm going from 0. But here's another point of intersection called A. You might be able to guess that value, but maybe you can't. So here's a sophisticated way to find the value of A. That rhyme was not intended, but God bless it. Anyway, we're going to take x squared minus x equals 2x minus x squared. That's the red minus the blue. And we're going to set them equal to each other to find out where those intersections are. So I'm going to collect like terms by subtracting 2x and adding x squared to both sides. And then I simply factor an x out of this expression and use the zero product rule. X is either equal to 0, which is duh, or 2x minus 3 equals 0. In order for 2x minus 3 to equal 0, x would be 1 1/2, so 3/2. Bet you didn't guess that. So now I can go down here to my integral. I can replace y1 with the appropriate function, and I can replace y2 with the appropriate function, and I could also replace my boundary. 3/2 is the upper bound for this integral. Now right here it's important to recognize that we are subtracting the entirety of this function, which is why we have to remember to distribute the negative before we actually do the subtraction. So that's what I did here. I'm trying to be patient with my work so I don't make silly mistakes. After I collect like terms, it should be pretty easy to find the antiderivative. Don't forget, in this notation we put the same boundaries, except this time they are on the right hand side of the square brackets. And then to complete the evaluation process, we simply put 3/2 in for x in both cases, and then we put 0 in both cases. In this case it should be obvious that the value of the function at 0 is 0. However, it's important to get in the habit of writing this because sometimes functions don't always equal 0 at 0. Anyway, the rest of this is straight up arithmetic, and you end up with 9/8. So that's how the paper and pencil algorithm works. The gist of it is you take the upper function, subtract the lower function, that creates a new function. We call that the difference function. And in order to find the boundaries, you simply set each function equal to each other, and that will give you the x values of intersection, and those are what you use for your upper and lower bounds. Now, if you're going to use the graphing calculator, which you should because it's a great way to support your work, one of the things you could do is enter this function, which is the full difference function, negative 2x squared plus 3x, or I did 2x minus x squared plus x. So you'll see here, that's 2x minus x squared plus x. I didn't want to risk making any mistakes, so I let the calculator do all the heavy lifting. And then I will show you in a second, I went to the calculate option and found the place where I can integrate under the curve from 0 to 1 1/2, and that's where I got 1.125, which you can see is equal to 9/8. Now with the calculator, you could enter in this simple equation right here, negative 2x squared plus 3x, but we want to make sure when we're using technology that we're also checking to make sure we didn't make any mistakes in our basic algebra. Sometimes it's the easy algebra that makes us wrong somewhere, and it's harder to find those mistakes because they're hard to find. So instead of trusting my own algebra to get to this resultant function, I'm going to use the calculator, and I'm going to put in either one of the equations for y1, this time that's the red, and then y2 is the blue, so I kind of crossed those, but I don't have time to change it. But the point is, I had originally the bottom function y2 minus the top function, so I'm just going to go to calculator. When I go to y3, I can do alpha trace, and that's the option to take any of these variables, so I'm going to take the y2 variable, and then hit the subtract key, and then go alpha trace again, and this time I'm going to hit the y1 variable, and that has created a function that is the difference function. So you can see here it's just that little speck of parabola down there. I would change the window, but that's kind of not the point. I just wanted to show you how to use the calculator here. So to get it to shade the appropriate area, you would go to second, calculate, and choose option number 7. As you can see, option 7 is integral of f of x dx. So as soon as I hit the enter, it's going to ask me for my boundaries, and the lower limit is 0, so I'm just going to hit enter. And then it's asking for the upper limit, and that's where I have 3 halves, which is 1.5. So I hit enter again, and the calculator shades the appropriate area, and then it gives you the value that you need. So bottom line is, when you're using technology, enter the first curve, the second curve, and then subtract them appropriately. Make sure it's upper minus lower. And then when you go to calculate, you can get the actual value of the integral. This is what you can do to make sure that your pencil and paper work is all accurate. You can also use the calculator to find the points of intersection. As you recall, I can just go to calculate, which I'm already there. Calculate. Actually, I would enter y1 and y2, and then I can go to calculate and choose intersect, and that would tell me right here, that tells me that one of the intersections is 0, 0, obviously, but I could find the other intersection doing that as well. So lean on the technology to make sure that your pencil and paper mathematics is valid and working. So thanks for watching. Sorry if this got a little bit long, but hey, it's under 10 minutes, so now you got the rest of the day to yourself. Anyway, try this. I'll post a couple other examples, and good luck. Have a good day.